So, admittedly, I'm really bad at smoking weed.
Go on.
Let's just say that at parties, I have major social anxiety when everyone's like, oh, here, smoke this. And I'm like, what is this? I'm a good Indian girl. Like, am I supposed to inhale? Am I supposed to inhale slowly? And now, of course, when you're a science journalist, everyone's like, you should know how this works, right? Like, you should absolutely understand this.
Yeah, you need to know everything about drugs. Everything about every drug and every scientific topic in general.
Exactly.
Totally. This is Tech Quickly, the tech-tastic version of Scientific American's Science Quickly podcast. I'm Sophie Bushwick, tech editor at Scientific American.
And I'm Tulika Bose, senior multimedia editor at Scientific American.
Scientists have just discovered, through the use of a smoking machine, the kind of joint that will deliver the most cannabinoid per puff.
That is wild.
I love the smoking machine. What they were using the smoking machine for was something you couldn't really use a human volunteer for without getting them inhumanly high.
Oh, okay.
Yeah, they wanted to test a bunch of joints that had different, they were packed differently. And the reason they wanted to do that is because they wanted to test just how much cannabinoid do you get from a joint. It's surprisingly hard to standardize. You might have the exact same amount of leaf in each one, and it could be the same strain, so it should have the same proportion of different cannabinoids, but you don't necessarily know how much of that is getting out of the joint in gas form and into the lungs of the person smoking.
And we had a freelance science writer who covered this for us, right?
That's right. Rachel Berkowitz wrote about this for us, and she found some really interesting stuff here.
I mean, I think we should probably start first by talking a little bit about how a cannabis joint actually works, right?
Sure. Joints are a very popular method for people who are either, taking medical marijuana or recreationally smoking. And it's essentially a paper tube filled with leaf particles of different sizes, depending on how you grind it. And basically, when you light one end of it, it heats up and the leaf particles burn and they release cannabinoids. So the two most famous cannabinoids are THC, which is the intoxicating one. It's what gets people high. And then there's CBD, which is increasingly popular for medical reasons. So it's been approved for treatments of certain kinds of epilepsy. But there's also some less substantiated hype around its use in other ways, like the idea that it could help with relaxation or reduce inflammation or other things like that.
So I guess, what are we trying to measure when we measure the performance of a joint, which is hilarious and it's a very funny thing to say, right? What are we really measuring? The concentration of these aerosols collected from each inhale? Or
That's right, because the concentration of the aerosols is going to tell you how much of this intoxicating component for THC is being delivered. Or if you want to use CBD as medication, how much medication do you want per dose, so to speak? If you're a doctor and you're prescribing medical marijuana to someone, you want to make sure that they'll be able to get the same dose each time, that they can rely on that consistently, that they're not going to get, one joint that has a ton of cannabinoid released and the next one very little. That's not useful for people who want to take it for medical treatment. Or for companies that want to say, we can offer a standard product. They need to be able to know how much they're giving people.
I was always confused because I would hear things about strain and I would be like, okay, which cannabis strain has the highest concentration possible of THC? Does that matter?
Right, it does. I mean, if you've got a higher concentration of THC, you'll get higher. But it actually makes a big difference what size the particles of plant in the joint are. So the researchers, when you grind up the dried leaves of the plant, you can have it end up being different sizes. So they tested 3 different sizes, pieces that were about 1 millimeter across, 3 millimeters, and 5 millimeters.
Okay.
And then for standardization purposes, they took these pre-rolled papers and into each one they put a different particle size. So they had one joint filled with 1 millimeter pieces of leaf and one with 3 millimeter and with 5 millimeter. And they put the same amount in each one. And they were testing 2 different strains of pot. One was primarily THC and one had primarily CBD.
So they used this machine called a smoke cycle simulator to pull smoke in for a set amount of time and then exhale it. Can you tell me more about how that works?
Basically, when a human is inhaling a joint, they're pulling air along it, and with the air, they're pulling in these aerosol particles with the cannabinoids and all the other chemicals that have been released from the burning leaf.
Right.
And with this machine, it's doing a similar pulling of air in, so it would maybe pull it in for 3 seconds and then pause, and then another 3 seconds. But you know that it's inhaling so to speak, the same amount each time.
The machine is inhaling.
Right. The machine, it's inhaling is probably not the correct word for it, but it's pulling air in a certain way and then pushing it out a certain way.
Oh, interesting. I mean, these scientists were probably having a lot of fun.
Oh, yes. I am sure they were. They even 3D printed a mouthpiece for the smoking machine.
What? No, they didn't.
They did. And what they did was they had these filters at the mouthpiece of the machine, and they could use that to gather the cannabinoid aerosols. And so they could tell what concentration they were getting. And they measured this multiple times as the joint burned. So you could tell how much is being released at the beginning of the joint, how much in the middle, how much at the end.
So what did these scientists find?
So what they found was that the 1 millimeter particles pack the most punch. You get the most cannabinoids from the smaller size. And they think that's because the smaller size has a bigger surface area. So more of the leaf is exposed to this heat, so that allows it to burn more efficiently, but it also burns faster. So the joint that was packed with the 1 millimeter pieces was burned faster, whereas the one with the 5 millimeter pieces lasted longer. So if you're rolling something that you want to last for a longer time, maybe you want to use bigger pieces of leaf in there.
So smaller chunks of leaf, more surface area exposed to the fire, which makes them burn efficiently and faster.
Exactly.
Got it. What was your biggest takeaway from this study?
I think that what was really interesting was that the researchers, they were specifically studying the effect of the leaf size, the particle size. But what they found was that they're just scratching the surface of some of these factors that affect a joint. One of the things the scientists noticed that even though they were using these pre-rolled cones, the goal was to standardize it, right? You want to make sure that you have the same amount of leaf in each one, that it's not being affected by things like maybe you roll it slightly more thin or more thick if you're trying to hand roll something. But even controlling for as many variables as they could, there were still differences between joints that were supposed to be the same. Because there's something like humidity has an effect. The density also with which you pack the leaf, that also affects it. So there's a whole bunch of things. Joints are really hard to come to a standard about because there's all these different factors that affect how much cannabinoid concentration is being released, including how far along in the joint you are. So one thing they found was that towards the beginning of the joint, you would get the most release of something called terpenes. So terpenes are these flavor-carrying chemicals. So when you inhale, that's what you sort of taste and smell. But towards the end of the joint is when you got the highest concentration of cannabinoid.
Okay, and it's so funny because I remember people hate the end of the joint, right? The end of the joint is like the gross part.
Right. Maybe this can explain it. Maybe it's because those flavor compounds have been burnt out already, and so what you're left with is just the cannabinoids and then the burnt leaf.
Oh, okay, this makes a lot of sense.
All of these things can have an effect. And because joints are such a popular method of marijuana delivery, I think it's really interesting to kind of dig into this and what makes a difference in how high you get from a joint or how much of the cannabinoid is delivered. Science Quickly is produced by Jeff Del Vicio, Talika Bose, Kelso Harper, and Corinne Leong. Our theme music was composed by Dominic Smith.
Don't forget to subscribe to Science Quickly wherever you get your podcasts. For more in-depth science news and features, go to scientificamerican.com. And if you like the show, give us a rating or a review.
For Scientific American's Science Quickly, I'm Sophie Bushwick.
And I'm Talika Bose. See you next time.